Hi everyone. So tonight I want to go through three problems that comes from chapter 12, which has to do with multinomial distributions. In particular, I'll be looking at a test for equality of proportions, a test for independence of two categorical variables, and then a goodness of fit test for a distribution to determine whether or not um, the observed frequencies fit a particular pattern or proposed distribution. All right. So I'm going to start off with the very first question, which focuses on equality of proportions. And here's what this problem says. So this problem has to do with the use of social media. Social media is becoming more and more popular around the world. Statistic provides estimates of the number of social media users in various countries in 2017, as well as the projections for 2022. Assume that the results for surveys in the United Kingdom, China, Russia, and the United States are as follows. So we have use of social media, yes or no is the question. And we have United Kingdom, 480 people said yes, 320 said no. China 215 versus 285. Russia 343 versus 357. United States 640 versus 360. Conduct a hypothesis test to determine whether the proportion of adults using social media is equal for all four countries. So right there and then we are being asked to find here, we're being asked to find whether there's evidence that the proportions are equal versus that they differ. As a matter of fact, we cannot prove that they're equal, but we certainly can prove that they differ. And if we do reject the null hypothesis, that is, we conclude that they differ, we must now go ahead and do a Marasculio test for equality of proportions to kind of determine which one is different from the rest of them. All right. So the way in which we do this is we have to total the columns and we have to total the rows. So I'm going to start off by stating the hypotheses for this particular question. So we want to determine if the proportion of social media users are different for the different countries. All right. So we're going to start off with our null hypothesis. And let me just change my pen for a second, because the pen should be, we're going to use yellow. Let's try that. So HO, this is HA. So we're going to say that the proportions are the same as HO, are identical, versus the proportions differ. Or at least two of them are different. If the proportions are the same, it means that we have four countries that we're talking about. So P1 is equal to P2, is equal to P3, is equal to P4. However, if they're not all the same, we don't know which, so we'll just simply say at least one proportion is different. All right. So that's the hypothesis for this particular question. The next step is to actually come up with the test statistic. So 2. The test statistic is a chi-squared distribution. And if we look at the problem again, we will see that the data that we have is obtained from counting. If the data that we have is from counting, then we could express proportions. So the data has to do with assessing some aspect of proportions, whether or not it's contingency tables or equality of proportions or goodness of fit tests and so forth. So this kind of data is used for that, where you have frequencies in the table. So 480 is the number of people, that's a frequency. All right, and so if we go back to our hypotheses here, we stated that already, and then our test statistic would just simply be chi-squared is equal to the sum of f ij minus eij squared over eij. Now you will recall that f is the observed frequencies, and ij represents I is the row, j is the column. In this case, we have 2 rows and 4 columns, and so it's simply a matter of excuse me, simply a matter of expressing the I 1 or 2 rows, j 1 to 4 columns, and so f ij is observed, eij is expected, and we have a formula for eij, which is that eij, and let me make some room here, eij is row total times the column total over this sample size, overall sample size, or the grand total we call it. Alright, so row total times column total over the grand total. So that's step 2 for this particular problem. Step 3, our decision rule. If we are told to test at a 5% significance level, right, then our critical value, chi-squared critical, is just chi-squared alpha, the degrees of freedom. But what is the degrees of freedom in this case? The degrees of freedom is k minus 1, where k represents the number of columns. And so in our case, we have 4 minus 1, which is 3. So chi-squared critical would be chi-squared 0, 5, 3, and we got to figure out what that critical value is. All right, so we're going to figure that out shortly, and we have to go to the chi-squared table. I'm trying to pull one up there very quickly. If I do this, let's see here. Go to Padlet and go over here. Let's see what we got. And I'm looking for here are my tables, chi-squared. So we're looking for 0.05, which is the value of alpha, and then 3 degrees of freedom. 0.053 is 7.18. All right, 7.18. So 7.18 is our critical value. So if chi-squared is greater than 7.18, we will reject the null hypothesis. All right, we'll reject that. Now let's do step 4. So step 4 is the analysis, and in the analysis we have to calculate the EIJ values. Right? So how do we do that? Remember, row total times column total over grand total. So we now have to take each of those values and do that. So let's see what we got. So I'll just do an example, one example. and then I will show you the complete set of values that we're going to need. So let's do EIJ. Let's do EI11. Not EI11, but E11. E11 would be row total, row 1 total, and row 1 total is actually 1678. Column 1 total is 500. No, 800, sorry, 800. But let me just kind of put the values down so you can see it. All right. We have social media. We have UK. We have China. We have Russia. And then we have USA. All right. And then we have our totals. That would be our row totals. And so it's yes or no. And then we have the following: 483.20. We have 215, 285, 343, 357, and then 640 to 360. So now if we add those up, we will see that we have a total of 800 over here. Our column totals: 800, 500, that was 285, 500, 700, and then 1000, which gives us a total of 3000 if we add them all across. And then this gives us 1678, and this gives us 1322. So to get E11, I need row 1, which is 1678, times column 1, which is 800, divided by grand total 3000. And that gives us a value of 447.47. All right, so that's our expected frequencies, and we could now go and calculate that for each of those cells. And if we did that, we would have the following result. Social media, yes, no, China, Russia, USA. The totals will end up being the same as the original totals that we had. So you get 447.47. Then you get 352.53. And when you add that, that gives you 800.53. That will give you 800. 279.67, 279.67, and 220.33. 220.33. We have now 391.53, 391.53, 308.47, and then 559.33, and 440.67, 440.67. All right, and then like I said, if we add those values up, we will get the same values that we had before: 800, 500, 700, 1000, 3000 is the total of those numbers, and that will give us 1678, 1322. All right, so those are your expected values. So that's expected, and those are observed expected. All right, now that we have those two, we could now find the components of the chi-squared. When I say components, I mean the value for each cell. And then when we add them all up, we'll get the total value of chi-squared. So I'll do one of them and then give you what the answer is. So if we're doing the very first cell, the first component for for the cell 1, 1, so chi-squared will turn out to be F, which is the observed frequency, so that's 480, minus the expected frequency, 447.47 squared, and we divided by 447.47. Alright, that gives us the first component, and then we just repeat the process for the second one. If we go across the row, then it would be 250. It would be for China 215, 215 minus 279.67 over squared. 279.67, and we continue until we get the very last one. All right. So we have 4 by 2. We have 8. The very last one. So if I do plus here, would be 360 minus 440.67 squared over 440.67 equal. And then that gives us the total value of chi-squared when we add up all of those values. So if we do that, we should get a value of 79.34, which is quite strong. 79.34 when we do all 8 of those and we add them up. So comparing to 7.18, we know that we're going to reject the null hypothesis. So that's our calculation. So step 5, decision, conclusion. So if we just use the critical value approach, we could say since 79.34 is much greater than 7.18, reject HO. Alright? And we conclude that we have sufficient evidence, or strong evidence, we have strong evidence that the proportions are not all the same. We have strong evidence the proportions differ. All right? Very, very strong evidence. Now, if we wanted to find the p-value, the p-value would be the probability of chi-squared greater than or equal to 79.34. To get that value, we have to look under the 3 degrees of freedom and then try to find 79.34. You're not going to find it. So we will basically have to use the smallest value that we have. So if we look at the values and we look along 3 degrees of freedom, when we get to 0.005 in the tail, the chi-squared value is only 12.838. Right? 12.838. So to get to 79.34, it would be a lot smaller than that. Almost practically 0. So it would be a lot smaller than 0.005. That we know for sure. So that's our p-value, and the probability, of course, of committing type 1 error is that p-value, which is less than 0.005. So the p-value is very, very strong compared to 0.05, and so we would reject the null hypothesis, no doubt. All right. So that's the hypothesis testing part of the question. That's part A, and so we have here the results that show that these proportions are not all the same. Let's go back to our question. What are the sample proportions for each of the 4 countries? Which country has the largest proportion of adults using social media? So to do that, what you would do is that you would just say, okay, what's the proportion for United Kingdom? What's the proportion for China? What's the proportion for Russia? So in that case, the United Kingdom would be 480 over 800. China would be 215 over 500, and so forth. All right, 343 over 700, 640 over 1,000. So let's just put these proportions down and see what we get. So part B, the proportions as follows. So UK would be, the proportions for UK would be 215 over 500. So if we multiply by 2, that will give us 4243.43. The proportion for China, CH, is 215. Sorry, I made a mistake about the proportions for UK. So we got to go back a bit more. I gave you the proportion for China. For the UK, it's let me just switch so you can see better. For the UK, it is 480 over 800. Okay. 10 is into 40 is 8. It's a 6 is to 4. That's 0.6, I believe that is 0.60. Then for China, P China is 215 over 500. 215 over 500. That is 0.43. For Russia, P Russia would be 343 over 700. 343 over 700. And that will give us essentially 0.49. And then we have P USA 640 over 1,000, 0.64. So looking at those values, we might say Russia and China are pretty close, but the UK with 60% and the USA with 64% does appear to be different from the others. So clearly, just on visual inspection, it would appear that these two are significantly different from 0.49 and 0.43. So those are the sample proportions, and I would dare say that these sample proportions seem to indicate some kind of difference between the proportions. All right, let's look at the last part of this question. Using a 5% level of significance, conduct a pairwise multiple comparison. All right. So in other words, they want us to do the Millar kind of a test, and I'll just sort of remind you of what that is, and then we could take it from there. So with Millar, part C, what we do is we do pairwise comparisons. We have to calculate CV, the critical value, right, which is chi-squared alpha df times, so the square root of chi-squared alpha df times P bar 1, or let's say P bar I, 1 minus P bar I, because since we're using I and J, over Ni, P bar J, 1 minus P bar J over Nj, right? So we have to first calculate all of those, and then if the absolute value of Pi minus Pj, P bar I minus P bar J is greater than Cvij, then we have evidence of a difference. Evidence of a difference between the two proportions. All right. So let's go about trying to calculate CVIJ and see what we get. So we're going to do one of them. Let's compare the UK and Russia. We're going to do one of them and then I'll give you the values for the rest. We're going to do UK and Russia. So we know that chi-squared alpha df was 7.18. So therefore we could find the square root of that. And then we need the value. So let's find we're going to do UK versus Russia. All right. Sorry, I meant let's do UK versus. No, let's leave it. UK versus Russia. That's all right. We got to do UK versus China, UK versus Russia, UK versus USA. And we got to go China versus Russia, China versus USA. And then we got to do Russia versus USA. So all the pairwise comparisons, I believe that there are 6 of them in all. So we're just going to do UK versus Russia. So the absolute value of 0.6, that's the sample proportion for the UK. Let me just remind you, P bar UK. Oh, I don't have to remind you, it's already up here. P bar, I forgot to put the bars on those things, the samples. So I don't need to repeat this. So UK versus Russia would be, and we want the absolute value, 0.6 minus, for Russia it is 0.49. So that basically gives us 0.11. All right? So that's that. Let's find the critical value. CV UK Russia. IJ, we'll call it CVIJ, is the square root of 7.18 times the square root of 0.6 times 0.4. And remember we had a sample size for the UK of 800 plus 0.49 times 0.51, and the sample size for Russia was 700. Let's see what that CV is equal to. So UK versus Russia, it turns out that CV is equal to 0.0717. So if we compare, comparing 0.11 to 0.074717, sorry, we could see that 0.11 is greater than 0.0717. That is, the difference is larger than the critical value. So we now have evidence of a difference between the UK and Russia. So evidence of a difference between UK, UK and Russia. All right. We have to repeat that for all of them. And if we repeat it for all of them, let me just give you the combinations. All right. Repeat that. So I'm going to give you UK versus China, UK versus Russia, UK versus USA. Then we got to go China versus Russia. China versus USA. And then Russia versus USA. So there's 6 of them. Let's look at the P I minus PJ, P by I minus P by J. So for each of those, when we calculate that, it turns out that we have the following differences: 0.17, 0.11, 0.04, right? 0.06, 0.21, and 0.15. All right. So that's those values. Let's look at the CVIJs once we calculate them. So now you would have 0.0786. And in case you're wondering, where do I get these values from? I would have to go and do this thing right here for every combination, right? So I just showed you how I did one of them. You have to repeat that for all the others, all 5 of them. There's 6 in all. So I'm just giving you the summary of the values for those. All right, 0.0717. Then we have 0.0644. 0.0814. 0.0750, and then 0.0678. Right? So now if we compare those, remember, if we could show that the absolute value of the difference is greater than CVIJ, then we have evidence of a difference. All right? So question is, do we have a difference? So difference greater than CVIJ. In this case, the answer is yes. The next case, the answer is also yes. I put 2 S's for yes. But then we have a no, no, yes, and yes. All right. So that's a Marasculio test. So only 2 of the comparisons are not significant, but 4 out of 6 of them are significant, giving us evidence that there is a difference between some of these proportions. All right, and as you can see visually, that USA is 0.64, UK is 0.6 compared to China and Russia 0.49, and then China 0.43. So those 2 countries won't be different from each other, China and Russia, right? And then UK and USA, because they both are pretty high, 0.6 and 0.64. However, when you do comparisons across the others with those 2, we find evidence of a difference between them. All right? So, folks, that is an example involving the tests for equality of proportions, and when we reject the null hypothesis, we can go ahead and do a Marasculio test to determine which combination of proportions sort of are significant in terms of a difference between them. All right? Good. So that is the end of this first part, which focuses on testing the equality of proportions. Thank you.